DevOps iterations.
And we are back with a new iteration, and this time is a deep dive on a specific tool. And the tool is Hashiqube from Riaan, which we already had the pleasure to host here. And well, basically the point is Riaan will tell us what is Hashiqube, how it works, and gives us introduction, possibly with some kind of deep insights in the technical parts of Hashiqube. So, Riaan, the stage is yours. Do whatever you want.
Alessandro, it's good to see you, and thanks again for having me on your show and allowing me the opportunity to tell your viewers and yourself about Hashiqube and how I think it can help people and what it is. And so I think maybe the best place to start is I will tell you where it started. So when I came to Australia, I was director of DevOps. And when I came to Australia, I was a consultant. And so when you go from director of DevOps and to consultant, you have to be on the tools again. Now, I've very much been technical all my life. I've used Linux and stuff, but here in Australia was the first time I had to really use Terraform. And not just Terraform, Terraform Enterprise, self-hosted on the data center, and Vault with replication, with Consul backend, with Jenkins doing the CI/CD, getting secrets from Vault Engine, and also Ansible Tower orchestrating some workloads, some configuration, getting secrets from Vault, signing certificates. And of course, this was all new for me. As you know, I'm Puppet, come from Puppet World, and I come from CloudFormation and AWS. And so back then, it was a very big client, a government client, and I had to quickly get on top of these tools. But I had a 2-hour train ride from the Central Coast into the office. And during the train ride, there was 45 minutes where the reception was very bad. It was up and down. We go through tunnels, then the reception cut. And so I thought, how am I going to learn these tools? And then Vagrant. I'm like, okay, I can bring up Vagrant in a Vagrant box, and I can install Jenkins Docker container, and I can install, Terraform there, and I can use local stack to practice with Terraform. And by the end, it worked really, really well. And I'll share the screen with you, and I'll just share this main screen, and I'll show you the integrations that I first started with Hashiqube. So there was the Jenkins that we had here, and there was the Vault that I could put in here, and there was Terraform and local stack, and of course VirtualBox. And this was by and large worked wonders for me. I was able to get on top of Terraform, learn this, use this, and kind of have a lab set up in my laptop. For example, when I tested Vault policies and I could not retrieve this secrets from Ansible or Jenkins, I was able to test this on my localhost, the policy.
So,
And
Riaan,
I could then go to the Vault administrator.
Yeah, so it started as basically a Vagrant environment with multiple VirtualBox machines, and inside the machines, the installation of these various tools, right? That was the first iteration.
Just
right?
one machine.
One machine
Yes,
with all
just
the
one
tools.
machine.
Okay, perfect.
With all of the tools. And I could then replicate these Vault policies and give this to the Vault administrator and see, well, you missed a / here, so I cannot look the secret up further down. But then I got a MacBook, and it was an M1. And the VirtualBox didn't work on the M1, and I was struggling to get this to work. At the clients where I go, sometimes they use Argo CD, sometimes they use DBT, or any of the databases, Postgres, and you don't always have a database available. You don't always have a Jenkins available that you can just spin up, but you need to write stuff on this. So then I tried to use it in Vagrant and with a Docker provider. And this, by and large, worked on the Apple MacBooks. So how I can maybe just explain to you what Hashicorp is I'll just show you this little diagram. So if you imagine, let me just make it a bit bigger. So if you imagine that this is your laptop over here, this whole thing is your laptop. Now, the two layers at the bottom is obviously your computer, and it's either a MacBook or it's a Windows or Linux or a cloud VM. Now, on top of this cloud VM, we are going to install Vagrant or Vagrant and Docker or VirtualBox. So if you use Vagrant with Docker, it's a Docker container. If you use Vagrant with VirtualBox, it's a VM. And then on top of this, obviously the VM, the Vagrant file will tell the base box is Ubuntu. And then on top of Ubuntu, we are going to install some tools like Bash. We are going to install apt-get tools, and we are going to install a Docker inside of this Docker. So it's Docker in Docker. And then we can install now Vault or Consul or Terraform or any of these tools that we want to install. But we can also install Kubernetes in the form of Minikube. And on Minikube, we can then land Node.js applications, AWX Tower, or Airflow, or Grafana and Prometheus, GitLab, all of these things. But we can also, alongside it, run Nomad. And we can see how these two orchestrators function. And we can run Nomad on, or we can run Trafic on Nomad, and we can run Trafic on Kubernetes. So basically, this is what it is. In a simple form, we check out a Git repository. We use Vagrant. This is if we want to run it locally. Now, you can also run it on the cloud or on all three clouds. So again, we check out. We use the Terraform Hashicorp module that I wrote. That's on the Terraform registry. And we can then spin up a VM with a Hashicorp on each cloud. So Google, GCP, Azure, and AWS. And then we can cluster Vault, and we can cluster Nomad, and we can test replication because Hashicorp can run enterprise versions of these Hashicorp software. So in a nutshell, that is what Hashicorp is. Now, you can either, as I said, you can either run it locally using Vagrant or Docker, or you can run it in the cloud. So maybe I'll just show you that is the simplest way to do it. So if we go to the Hashicorp website over here, then you can read a little bit about it, and you can see that the way to run it is in GitHub code spaces. So you can watch this video to help you, but basically we are going to go to the GitHub repository of Hashicorp. We can fork the Hashicorp repository. And then in this forked repository in your own GitHub, you can launch a code space. Now, what this will look like is pretend this is your fork. Now, if we drop down here to code, you will see here we clone it, but there's this new tab called code spaces. And if we say create code space on master, it will bring up a VS Code window with Hashicorp inside. And it will be fast because I have a pipeline that already builds the Docker container. You can also say that it must build the Docker container. And if you can imagine, then over here, it will actually build the container instead of just pulling the layers. And you will see here now, it's actually just pulling the layers, and you will see it's starting to pull them now. So at the moment, what it's doing is it's just starting a Docker file. And this Docker file is in here. And it just looks like, if I just quickly look for it, a very bare minimum Docker file. But one thing that I do is I'm trying to get systemd to run. And this Ubuntu supports all the architectures. So there is a architecture for ARM64, AMD64, and so on and so forth. And we are just going to get prep systemd because our entry point here is init, is systemd. This is our command into the container. Now you can see I download the Vagrant public key here, so we can also SSH to this thing. And the trick is it should act like kind of a VM where people can test it, they can access this thing, they can see it. So this is basically what it's doing. There's one point that's worth mentioning is that we mount this volume, the C groups FS, and what we are going to do here is I just want to show you the Docker compose. This is important. So we say privilege true because we are going to drop into root. We want to enable the TTY and we want to say the C groups is host. And then we want to mount inside var lib docker, we want to mount tempfs. This is because inside of overlay fs, you cannot mount overlay fs. You cannot have overlay fs on top of overlay fs. Then you must use something like VFS or something. It's very, very slow. But we can get around this by using temp space, and then we can then the Dockers can live in temp space. It's not overlay fs. Now, as you can see, it's already up and running, and you will see this little menu. Now, if I just open up a new tab here, you can see you can run top with the CPUs. You can see how much memory we've got here. You can run df space -h. All of
here,
these
sorry
goodies.
to interrupt, just let me ask some. This is the terminal inside your Docker container, which you just started, right? Okay.
Correct, yes. So this is a terminal inside the Docker container, and you can see that var lib docker has been mounted here. But we don't yet have Docker in here.
Okay.
So to bring up Docker, we can just do bash docker and docker.sh. Okay. Now, when you do vagrant up -- provision with Docker, it will just run these shell scripts on the side here. So if we say we want to bring up Docker, it's going to run this docker.sh.
So the point is within this is the, let's say, the big container with the systemd and everything. And from here, you can install inside this container all the tools you want. Docker inside the Docker container, Terraform, Hashi, any Hashi tool, and so on. Right? Okay.
Correct. Yes.
And
so here we are.
The installation of the various tools, you have these scripts. There is a place to understand what are all the tools, the scripts to run, the tools available.
Correct. So if I just show you here, for example, Docker, they will just tell you a little bit what Docker is, and if it's too long to read, you can do vagrant up provision with Docker. I'm still update this to show the code spaces way. But basically what it will just tell you is it will show you the script we are going to run and a Docker file, because I also use this for training, how to build a Docker for people that has never built a Docker. What is a Docker file? How do you build a Docker file? How do you run a Docker file? And so this, what it is now doing is it's now installing Docker for us. It's got the Docker registry that we are installing also in here. And then it will just now take a second to start up. We will do Docker PS, and it will show us that we've got the Docker registry running. And now at this stage, we can do Docker info. And this is a Docker daemon running inside of this Docker container. So here you can see we've got C groups version 2 and systemd. And it's important that we have C groups v2. It's quite important because I don't think kubectl exec works with C groups v1 anymore. So, and you can see that the storage driver is overlaid 2 on tempfs over here. So now at this stage, we can do Docker PS and all of this type of stuff. And now we can also do bash. And for this, we are going to do nomad, and we are going to do nomad.sh. So again, it will just execute this nomad for us, this sh file with some nomad jobs that is in here. And for the purpose of this demo, we are just going to run the Fabio job, and we are going to run the Trafic job. And you can see the Fabio nomad is over here, the template. And you can see here is the link that I left you for Fabio. And then the Trafic job is over here. This is a Nomad job template. So we can tell it the dashboard where we can go for this, and we will see this services register in console. So this Nomad script will also ensure that console is running for us, and it will start console for us first. And so here you will see that it is bringing up console, and now it is bringing up Nomad with the CNI plugins. Oops, let me just go here. And it will just start the Nomad services for me. Here I'm using set and tail to look for client node registration complete, and then I break out of this tail. So I use set and tail to look for a particular string, and it is kind of like a dynamic wait condition. So here we can see that the Traffic job has now been started. So Nomad job run, and here it is evaluating. So maybe it's worth that we just go to Nomad. So we can now look at port 4646 and open it in the browser. But what I'd like to do, and this is the real power of these code spaces, is I can go port visibility public. And so I can copy this URL for you, and I can paste it here in our chat, and you will be able to open up this Nomad screen. So here it is busy now pulling the Traffic container and starting this job up.
Yeah, I confirm.
Now
I see the same thing you are seeing from my browser. That's wonderful.
Yes, so you can see how you can use it in your pipelines with a token or something to really use it as a testing framework. But now this is really nice. Nomad is very, very easy to bring up. And in fact, it's got quite nice features. So for example, we can see the task groups, and we can see the containers that are running. Over here, we can view some logs of this container that is bringing up, and I don't think it has any logs here, but normally you would see some logs over here. But we can also exec into this. And so if we exec into this server, and it doesn't have bash, but I know it's got sh, then we can exec into this container, and we can kind of get access to the container, which is very, very nice.
Just to clarify the levels of containers we have, this is the traffic container inside your container where you are running Nomad, correct? Which is inside.
So Nomad is not a container.
Okay, you're right.
It is,
but is
just
the base container, the one you created with Hashiqube, no? Inside there you installed
Yes.
Nomad. So basically this is a
Yes.
container inside a container, just 2 levels for the moment, right?
Just 2 levels for
Just
the moment.
2 levels.
Yes.
inside
Just 2
something
levels.
which we don't know what it is, the code space on on GitHub. But okay, that's another matter.
Later,
Okay.
I'll show you Minikube. Later, I'll show you Minikube, and we'll see how that, because that will be Minikube, which is a container, inside Hashiqube, which is a container, and we'll then have pods inside those containers.
Yeah, there we will add more layers. Just to clarify, show better the ports thing in the GitHub code space, just to, because that's the interesting part as well. Yeah, there is this interface for each service you created. It created a port which is open and can be reached, can be made public. How do you make it public and reachable from outside?
You just right click on here and you go down to port visibility.
That's the thing, and that's very cool.
Something which I must give kudos to the guys at GitHub. So initially, look how beautiful they've done this. You see they put the port inside of the URL.
Yes.
So it's all over HTTPS, it goes to different ports, but they have the port inside the URL. So you don't have to go :4646. None of that nonsense.
Right.
And I thought it's quite beautifully done. I just want to say, well done. That was nice.
Yeah.
You know, but yes. And so now this guy, this nomad has running some jobs, but the thing that it's actually connecting to is it's also connecting to console. And I want to show you console. So if I go here to port 8500 and I open in a browser, and I'll make this public for you as well, port visibility, and I'll share the console with you. Copy. I'll paste it over here for you. There. Then you can see that there are some services that I've registered in console, and these are just a config file, kind of like DNS. So console has this console, Doxify, Hashiqube, and Vault DNS prefixes. So you can dig against console. You can do DNS resolution against console. But it also has jobs which are registered from Nomad. And these then have other instances and checks that you can have. Now, one way that I use console and Nomad for some clients is all the jobs in Nomad automatically registers in console. I then enable the telemetry on console, and I host Prometheus and Grafana on Nomad. So I tell Prometheus to get the endpoint from console, scrape those metrics, and then I can have a Docker dashboard or a Nomad dashboard or whatever console dashboard, and then I can see the stats for these workloads. But I can also connect Alert Manager into Prometheus, and so if the job then fails on Nomad, it would sync all the way through zero config to be able to alert me with that. So it's very, very powerful. Now, so this is for Nomad and console, but we can also run Vault in here. And so at some stage of the game, this thing will crash out, but let's just see how far we can go with this, because it's only got 8 gig of RAM with 2 processors, and it's free, and we are just going to keep on going until this container says I can no more.
Yeah.
And
Yeah.
so let's
Just
go after Vault. So after Vault, we will look at Boundary from Hashicorp, and that's the credential broker. So it's very transparent. So you get access to Boundary. Boundary is a target that you can click on, and then it will open up a tunnel, and you can then connect with a MySQL Workbench or via SSH to these endpoints. But you never see the credentials. So you only have SSO login to Boundary. So if you imagine that you cannot leak credentials which you do not have in the first place, it's actually quite nice with session recording. And I can imagine for banks or for people that want to secure this. I mean, VPNs, this is the problem I have with VPN, is once you are inside the VPN, it's kind of open in the inside. And VPN is too open to just allow certain places with logins to just certain things, where I think perhaps Boundary and ngrok, they do these things better now. So here we've got Vault running now. So this is on port 8200, and we'll open this, and I'm going to make this public, and I'll share this with you, and I will share the token with you as well. There. And so the token now gets printed out here, the initial root token. So I'm going to copy that, and I'll paste it in here for you. And if we log in here, now we have Vault running over here. Now you can see that there is no secrets engines yet. It's just got cubbyhole. There's no secrets engines. But how does Vault actually work? So one of the ways that you can do this is you can enable the database secrets engine, and we can then use Vault to enable the brokers for us. We can create a username for Vault in MySQL, and Vault can create temporary credentials for us and also purge these credentials. So let's see how we do that. So in here, we can run bash, and in databases, we can run mysql.sh. And what this will do is it will bring down a MySQL container for us. And it will check that Vault is running. It will install MySQL tools for us, bring down a MySQL container, enable the Vault secrets engine over here. If we go here, MySQL, you can see everything here is, it will enable Vault is running. It will then source the environment variables for us. It will then bring up a MySQL container, or it will bring up a MySQL container with a password and the root password that we know of. And then it will show databases, and then it will create a Vault user in MySQL. And this is the password we are creating with the password, and we are then going to pass, we will grant all privileges to this Vault user in this MySQL, and we are then going to create a Vault config. So we are going to say the plugin, MySQL database plugin connection, and we will specify the endpoint of MySQL and the role that it must use and the username and the password. And then there is a create statement that Vault uses. So it can go create user, some name, identified by password, and grant all privileges to this name. So which means that that Vault will create these users for us. And here we will select the user host for MySQL, and we will ask Vault to create the access for us. And we will then print out the user that Vault has created in here. And I'll show you that Vault will create it with a time to live of 5 minutes. So the TTL will be 5 minutes that Vault will create this user with. And so it can then time it out in 5 minutes. So you will see default TTL, which means that in 5 minutes, that user will no longer be in MySQL. Now, of course, 5 minutes in production is a bit low, but you would typically make it, let's say, at every build, a new user would be generated, written to some environment for the container to get, and then every other day, the container would expire. And this is how you can have these rolling secrets. So here you can see that Vault has created this user for us. And this is the username. So we can go MySQL-H-U. If we just copy this quickly.
You have 5 minutes to
Copy,
that. Right.
and we just paste it. And then let's see if we can get the username. Oh, my middle click doesn't work, which is a pity because I love the middle click paste. And then -P, this password. Copy, and we're going to paste it. So we should now be able to connect to MySQL with this user that Vault has just created for us. Then we can go show databases. And in 5 minutes, this user will be removed. We will not be able to connect with this anymore. And if we look at Vault again now and we refresh these engines, then we can see that. Let me just grab my token again quickly.
Yeah, I see it in my interface.
Yes.
Yeah.
And so basically what this is doing, sometimes people tell you, oh, Vault, you must use Vault. You must use all of these software. But for engineers and for evaluators like CTO, this is incredibly powerful because you can already start dreaming up use cases, how this can, wait, I can use Vault as a encryption in transit to get my credit card details from the web app, encrypt it, and post it in the database. And when I retrieve this from Vault, it's in the fly, in transit, decrypted. So, the power of Hashiqube is really you can use this thing right here, right now. You can run containers. And if your people working for you doesn't know how a Docker file works, you can really use Hashiqube. And what this does is it elevates the confidence of the people, because they can break Vault and throw it away and just start again without having to go to.
Just to get a bit deeper, because one thing is, okay, I have the interface, I start to play with it. Most of these tools have an interface which allows you to do most of the stuff. But if you want to maybe start to work on something on the application itself, can you explain us a bit the structure of the directories here, and eventually how you can do some deeper changes in the tools?
I can, absolutely. So I try to keep it very flat. So if you see here that Ansible has got some Ansible Galaxy and Playbook, and Ansible Tower will be Ansible Tower. Now, these directories correspond to a menu item here on the side. So for example, if we go Ansible Tower, I will tell you a little bit about Ansible Tower, where you can visit this, how you can install it, where you can read the docs, and then from Red Hat. And then I will show you when you provision this, it's built kind of like Lego. So to enable to run Minikube, you must have Docker. In order to install Docker, you must have a base tools that install curl, wget, all of these things for you. Doxify is the documentation, and this is the website you see here. This is a Doxify website, but you can run this locally. So you've got this whole copy of the site, everything locally that you can read and go on and so forth. Now, to run Ansible Tower, which is installed with Helm, you need Minikube. So, and all of these Minikube, Doxify, they are just provisioners, and they correspond to a folder here on the right. Excuse me. So Local Stack and Mermaid and Minikube are all just integrations. Excuse me, are all just I've got a frog in my throat.
You are talking so much, so yeah, I let you wait a moment. No, that's very interesting. Yeah, so
very flat. It's just bash.
And inside the directories, typically you have the script to install the tool, and whatever is related, the documentation. This the same README is the same thing that you see in the web page. You say this README.
Correct. Yes, the README. This is the logo that you see here for console. So if I show you here,
and
if we go here to console,
so we said now we are using it on code spaces on GitHub. When you run locally, you clone the repository, you run a Vagrant app with the provisionings which you want. By default, that Vagrant app creates VirtualBox, or what is the default?
So that's a good question. The default I've made it is in the Vagrant file. You'll see over here. I've made the default provider as Docker.
Good. So by default, wherever you are, you have Docker locally installed, you run Vagrant app and whatever, you create
correct
the base big systemd container, and inside there you can run all these stuff.
That's correct. That's correct. And then the ports, here are the ports in the Vagrant file, but if you look at the ports in the Docker Compose, then here are the ports. And they correspond to Vault and Nomad. All of them have been mapped out what these things are using for. So, and then these are the ports that you are now seeing over here. These are the ports that will start lighting up over here.
Okay, explain me something, because you said inside the Docker, the Vagrant file, you run a single container with systemd, right? And then the Docker Compose with the various what you use it for.
So the Docker Compose is used for the code spaces.
Okay.
So I'll show you the code spaces now. So in the Vagrant, you can see there's some tools, but there's the Docker provider, and we have the dir, the SSH, the privileged true, and then we mount the create arguments. We mount into sysfs and tempfs over here, and tempfs we mount, and then it brings up a Docker container. Now that's local with Vagrant. Now with code spaces, with a dev container, is if you look at this dev container, I pointed here to a Docker Compose file. And the reason I do this, dev container has got features that you can just say enable this feature and the dev container will pull it in for you. One, these features might not support all architectures. And two, I cannot use that feature in a pipeline. So I want to use a Docker file that I can build to a public registry. I want to use a Docker Compose because I can run this same Docker in my pipeline. So, which means that if I install Vault in here and I run it locally and I test it and develop against it, I will have the same version as Vault as on my pipelines. It becomes very consistent. So if you think of Terraform in a dev container, Terraform gets installed for you using tfenv or tenv or whatever with the Terraform version file. So this same container your developers use, the same container your build agents use, everything uses the same container. So which means that your dev becomes very, very close to your non-prod and your prod accounts because they're all using the same version. You know, you are not using some let's say Azure extension to install Terraform for you in the pipeline, and now something is breaking like Terraform 1.10 because your AWS S3 backend has changed. You know, it's all the same. It's all the same. So nevertheless, here it points to a Docker Compose file. This Docker Compose file then points to a Docker file if you want to build it. But in this case, I just pointed to an image which I built with GitHub Codespaces already, and I published to GitHub Container Registry. Now, so far so good. We've looked at the Hashicorp tools. Maybe I can just quickly do Boundary. Let me just show you Boundary, boundary.sh. So let's install Boundary. It's the community edition, and we're going to install the latest version. But if you want to install production or enterprise editions, you just drop your Hashicorp license, your license.hclic file inside of this folder, and you bring it up, and it will detect the license and download the enterprise version for you, and so on.
By default, I guess you always install the latest versions, no, of the various applications. The one which is
correct. Yes, and the open source versions for Hashicorp, because I don't have the license and people just want to evaluate it and test with it and practice with it. And so for students to get started with this is extremely easy because now they are actually running something. They are already building stuff. They are already hands-on and becoming curious and being able to use these commands. And so far it's free. So my child, he's 10 years old. He's already running Hashicorp. You know, they sometimes play video games and everything. And I bought him his first laptop for his birthday. Come say hello here quickly. Yeah, sure. Say hello to my friend Alessandro.
Hello.
Ciao.
I'll close. So he's already running Hashicorp because I tell him I can let you play games, but
Only if you
must
learn
spend
the tools.
30 minutes. Well, you must spend 30 minutes for yourself. And I would tell him, go to Hashicorp website and click on Vault for me and follow this tutorial. Like, watch the video, go through it, bring up Vault for me. And if you have any questions, let me know. He doesn't know what Vault is. He doesn't know what Hashiqube is, but he's already learning to follow a tutorial, to watch a video, to learn. And then later on, I would ask him questions. Oh, so what is the problem that Vault is trying to solve? And then you would like, that guy, he spoke something, whatever. So I'm doing it like that. And so now boundary should be open. And if we go to boundary, it's port 192.0.0. So if we go here to port 192.0.0 and we open in a browser, and in good old fashion, I'm going to make this public for you. And we Control C here and we paste it over here. There. And so to log in, it will tell us we must use admin and password. So if you type in admin and password, we can log in. Now, what you see here is some boundary with aliases and targets. So these aliases, you can SSH to boundary.dev, which is the local host, and Postgres, you can access Postgres. So if you click here on Postgres, you can, where is this? Actually, let's just go back to this target over here. You just see workers. This guys are workers. Just see here. So you need the boundary client to connect to it. Now you can install boundary client, and if I go here, boundary, then we can open boundary. And what it will do is ask us for, it will ask us for our boundary URL, which is this guy. We're going to copy this, paste it in here, submit. Unable to connect. Let me just quickly see. Is it this guy? Just quickly see. Okay, let's see here. Did I make it public? I wonder if I made it public. 112.0.0 port visibility. It is public.
It's public. I'm inside. So
in through alt disconnect. Okay, so probably this is the demo gods. Doesn't matter.
Maybe
this is boundary.
And it connected. No, you can. Okay, no, it's okay. Go ahead.
Yeah. So if I use the client, then we can connect here, but it doesn't do what it should be doing for us now. But nevertheless, I want to show you just lastly before you can ask me questions. Let's bring up Minikube. So at some stage, these things might not start dying.
A PS at top on the Docker to see what is the situation.
So it's Docker stats pipe to cat.
Okay, so which is a top from the terminal, not a Docker drop, just a top.
Let's see, top.
Okay, so it's it's keeping the memory is starting to there is still buffer.
It will start falling apart now. But remember, it's only 8 gig of RAM, and we've already evaluated a lot of things, quite a lot of things that are still running here.
And actually, so you can change, and in fact, you told me you can change also how fat is the code spaces machine. No, you can make it bigger. Let me show it maybe again.
Correct. You can go here. And then if we go here in the code spaces, we can right click here and we can say change the machine type, and we can make it to 4 cores. And so I'm going to say update. And next time if this thing dies and we start it up again, it will come
The
up
big,
with 4 cores and 60
all free, courtesy of
gig RAM. But
GitHub.
nevertheless, let's see how far we get.
Yes.
So what this will do is it will bring down Minikube for us and install the Helm dashboard and install the Kubernetes dashboard so that we can start getting familiar with Kubernetes and we can run it on our desktops or locally or in GitHub, wherever. And now you can imagine if you get the kube config and you get this into your pipeline, you can run kubectl commands against this thing. But you don't need to go through EC2 and bring this up and get security groups. And it's everything right here. It's truly what GitHub has done with this is just, it's absolutely fantastic. Can you imagine being able to develop like this in today's day and age? I mean, who would have thought that as ops people, because I started as a system administrator, that we'd be working in IDEs? You know, I was always working in a terminal, and we have got a terminal here, but we are working in VS Code, in an IDE. It's incredible.
Yeah.
So times have really changed. So we just give this a little bit of time. It's busy starting the Docker container in here now. And we'll see what's happening here. And we hope it's gonna work. I think it will work. So here it's going to take 5 gig for Minikube.
Maybe is there a way to kill one of the applications in a nice way so that you leave some resources?
Yes, there is. So we can just do service nomad, and we can go stop, I believe. And if I go psaux pipe grep nomad, then it's gone. And we can then also go, because I created system D script for them. Service console stop. The other stuff you will do kubectl delete ns to delete the namespace, and then these pods and things will die. But if we go, and the other one is docker stop MySQL, I believe, and then docker ps. So now it has killed the MySQL. Now, okay, so here it has brought up Minikube. It is installing K9 CLI for us, just a little tool, help people evaluate it. Now, I just print a little message here that some of these containers will now be coming up, will now be starting. But initially things will kind of be broken, but this is fine. They will rectify and rebalance, so to speak, come up again and start. So this is a little error, and it's okay. Some errors, you will get errors, but this thing will always try to roll forward. And so we are just going to give this another second or so to print out the Kubernetes endpoint for us. So Vault is so Nomad, and that is dead now, and we killed this. So if we go here it will just port forward to the registry for us. And this is an unauthenticated registry.
Okay.
So we have the authenticated registry, which is the Docker run, which we brought up the Docker registry. And then we have an unauthenticated registry here for in case we want to pull images with Helm, local images that we want to build, and we want to test our manifest, and we want to. So I have the authentication registry and the unauthenticated one, which is here. And we'll just see whether this guy comes up for us. We could do, if we su to Vagrant, then we could do kubectl get pods, also all namespaces. Oh, Let's quickly just see here. Yeah, it might have died, but we'll see now. We'll see what happens. Just want to see something. Maybe. We'll just let this.
Let's wait. Well, maybe, yeah. I don't know, resources to free.
If this doesn't work, I'll show you how quickly it is. It's truly incredible. So this, I'm actually hoping that it's going to fail. And in fact, let's file this here, because then we just close this and we go here and we go to code spaces and we say stop the code space.
By the way, can you have
And then it refreshes.
multiple code spaces open at the same time on the same browser, on the same repository?
Yes.
Okay.
Yes, you see, it gives it different names.
Okay, so you could have the other one in a place and then create a new one and do other stuff. Wonderful.
Yes. Okay. So here we will just see, it might have been a little bit quick for it, but we will just start it up, and this time it will come up with 16 gig RAM, and we will just run Minikube just to start Minikube.
Yes.
So let's just see. It's still just stopping it. Sorry, it was raining cats and dogs here now, just a couple of minutes ago, so maybe we are too quick for it. Let's just quickly refresh this, and we will go open in a browser. So it's still stopping.
While this stops, can you just create a new one, or?
I stopped it, and because the Minikube wasn't coming up, so I stopped it, and I want to launch it with a new RAM that is coming up. But here it is still saying stopping. So
my question is, you can't have another code space created from scratch while this is stopping?
Oh, you can.
So let's do that.
You can. You can set up a code space. Yeah. It is. And so where this really becomes valuable is, as a consultant, sometimes these companies must send you a laptop so that you can work on their environment. But now with GitHub, we don't need a laptop. We need SSO login to the AWS account where we are going to test. We need code space access, and we need access to a repository. And in the Docker file, we can bring up our own Terraform, our own Packer, our own Ansible, whatever we need, TFENV, check off all of this, and we can operate against AWS. We don't need a laptop, a physical laptop.
Can you just maybe take the occasion to explain a bit better the DevContainers file and so how to create your own DevContainer? So a more general topic, since you did a wide use of this.
I want to show you this one, the Terraform modules library, because this is a bit of a better example for. So this, as you can see, is a Terraform project. And what this basically does is it helps people who has to develop a lot of Terraform modules to run pre-commit and checkoff and all of these linting and static code analysis tools against a lot of modules. So if you look in the Terraform folder, you will see there is AWS and Azure and custom and GCP. And if you look in AWS, we've got modules, and we can have a bunch of modules. And then we can have patterns which are using these modules. So we have a module EC2, and then we have a pattern single Linux server. And the single Linux server just uses the module EC2, but with variables already populated, that the AMI is a type Linux, that the user data is this, or we can have a Windows server fleet. And then it also uses EC2, but it has also auto scaling on top of it. Or you can say Windows server fleet behind ALB. And so you can make these patterns. So what this thing does is it can help you develop your modules. But if I just show you in this dev container, you'll see a dev container.json. Now, in this dev container.json, if I just maybe make it a bit larger for you, you can see that we have some post start commands that we want to run, like Terraform, make the plugin this, so our Terraform cache will work. We can pre-commit install so that our pre-commit hook is set. We can then print a message of the day when it comes up. And here we can specify VS Code settings. So editor, size, font size, scroll back, and we can specify extensions. Of course, if you have a Python project, this would be different. This would have Python extensions with some Python settings that you want to run and test with. And then in this dev container, again, it points to a Docker compose file. And this Docker compose file looks like, if I just quickly look for the Docker compose, let me just quickly find it. If I just go here, so it would point to a Docker compose file, right? And here you can see that we just mount the app, but here we say if you want your SSH or GPG keys, and here we have our environment variables, which will be available inside of this dev container. So you can authenticate here on your laptop, and when you start this container, transparently, the credentials will be available in the container. Now, this is using a container that has already been built by a pipeline, but I want to show you the Docker file. So the Docker file in here is now more specific. We are installing things like JQ, Python, update MOTD, rsync, DOS to Unix. We are then installing Hado lint, which will lint our Docker files for us. We then use tfenv to use this Terraform version file to install Terraform for us. So if I show you Terraform version, then this will be the version which is in the container. So we then install Terragrant, TGENV. We install tfsec. We install Trivi, tflint, the Terraform docs plugin. All of the things that we need to do for our project to do its thing. Now,
Okay.
what I'd like to show you is I just want to show you the power of this. So in the container, you develop against it. You have a Terraform version. In this GitHub workflows, again, we build the container. We just build this container and we say we want to build AMD64 and ARM, and we publish it to our GitHub container registry as latest. That's the first job. We build the container. Now, in the very second job, we are using this container to run Terraform version, install pre-commit, do run.sh. And run.sh is just a set of scripts that we are running. It's a kind of a pipeline that we can run locally to do pre-commit, run all checks, make clean, init all of our modules for us, run checkoff and tfsec for us, Terraform format and linting and all of this. So you can see how this dev container helps you with the maturity of your project and your developers by and large. So this kind of forms the basis for the technology for a center of excellence.
Indeed.
Because you see it, this becomes the foundation, and this is the
Okay,
the
let's go
dev
back
container
to
in a
our
more perfect form.
Kube container.
So now we are just going to do bash minikube.sh. Now, in the scripts already, we check if Docker is running. If Docker isn't running, it's going to start it for us and do most of the things that it needs to do. So it will just download Docker for us, install Docker, and then start bringing up Minikube. Now, if you have this locally in a dev container, it works exactly like this. If you clone it and you open this in VS Code, what I'm doing here, you can do exactly locally in VS Code. You just need to install Docker Desktop. And I'll tell you now why I say Docker Desktop. I can tell you now, actually, because in the companies I work, there's people using Intel Macs, there's people using ARM Macs. There's people using ARM Mac 1, M2, and M1, and Windows. And then there are people who install WSL, and inside WSL, there's Ubuntu or CentOS or Red Hat. In order for the company to have just small tool set, just ask him to install Docker Desktop, VS Code, the remote container extension for VS Code, and Git. And that is it. That's all. Then doesn't matter whether you are on Windows or Intel Mac or ARM Mac or whatever, we don't care. This will work. And so for that reason, I say Docker Desktop. The licenses are cheap anyway. It's like $8 for a desktop. And if you use Windows, well, you need a license. Azure DevOps license, Lucidchart license, Windows itself, client access licenses. Everything needs a license these days. So, okay, so now it's brought up Docker. And now it is going to install Minikube for us. But you can see if it crashes, it goes away. It's not a big problem. We just spin a new one up and we carry on. And by that end, we kill it off. And, your files are still saved. This thing has a state. So if you were editing a file and it breaks or the container crashes, your state will still be there. Okay, so this is going a little bit quicker now. No wonder. But it's not to say that the applications running inside of it will come alive again. That we have not taken care of. So we're just going to wait for this guy to quickly download. Should be nearly done. And then I'll show you the Minikube, the Kubernetes dashboard. And then that's the demo. So at the moment, I'm trying to get Ansible Tower to run in this code space, but they have updated the cross-site scripting domains, and I can't get that to be recognized. I have a little issue on here, and I posted for help in the Ansible, the AWX Tower repository for help, but I've not been able to get it to run yet. I'd love to show you that because it's really incredible if you see Ansible Tower connecting to this Docker, running an Ansible playbook. It really opens up the doors what is quite possible with this thing. So here it's installing K9 CLI for us. And so you can see K9S is over here, and maybe we can just do A. Okay, so we're just waiting for the context, but it's probably not alive yet. And we'll just give it about 30 seconds for this guy to come online. And here we go. It's installing this ingress add-on for us. And then it will also install Trafic for us on this Minikube. And so at my work, I run K3S instead of Minikube, but they are both the same, both works the same. It's just two different implementations of the same thing, really, Okay, we should be nearly done. Our registry. And then you can see the same here if you go to Minikube. You can read up about Minikube, what it is, show you the Minikube dashboard, the Kubernetes pods, the Kubernetes services, and then some little bit of commands that you can help you with. And then the Helm dashboard, what you will see when we install the Helm dashboard. And here I've run Airflow and Grafana and Prometheus and Trafic and Waypoint on this Minikube where I took this screenshot. And the K9 CLI.
So, are you receiving some community feedback, pull requests? There is some help from others, or is all as usual? Well, not as usual.
Well, there are some. I must admit, I've been quite fortunate. Some people has contributed through the years. It's been 4 years now, and so you can see a lot of these guys.
Okay, so
And,
if
people
what
have,
is the
have helped with this.
what is the most welcome kind of contribution? What would you like to have from users? Or,
It's difficult to say. Maybe just some feedback on how they use it, or if they can put more things in there. Like I put DBT in here, or Apache Airflow, or Argo CD. I mean, there's a myriad of tools that I don't even know that people can work, or I only do it to get started and see where this goes, and I have my own way of implementing it. But someone else might want to put the vault inside of Kubernetes to manage the secrets that way. There's various different ways of doing things. As you know, this technology is quite powerful. So what we can do here now is if we
so
click
adding
on
a
ports,
tool, support for a new tool will be a matter of creating the directory, creating the script which installs the tool inside the container. What are the various steps? Okay, here we have the interface, and that's it. Wonderful.
so I'll tell you the various steps is we would create a folder in here. Let's say, for example, Argo CD.
Okay.
When I created Argo CD, I would create here a folder Argo CD, and I would start with a README and argocd.sh. Now, I would start reading the documentation, how to install Argo CD. I would then check for which architecture I'm on, which is copy and paste kind of. And then I would start from ensure that Docker is running. And then I would ensure that Minikube is running.
So at the end is mostly
And
the
now
installation of the tool within the Docker. As it were, okay, it's inside the container, but it's as a normal installation inside a Ubuntu.
Correct.
Yeah. Okay. With all
Yes.
the details.
And then there's yes, the kubectl Argo CD, get the file over here to install it. And then we are looping and we are waiting for the service to become available. And then we can do patch Argo CD and change it to the node port. And then eventually we can get access to Argo CD. And then here I've left it to do what I must do. So other things that I've used, I needed to do a little bit more. So you can see here in Ansible Tower, there's a lot more links. You can see once I bring it up, I connect to Ansible Tower and I check that AWS web interface is available. But here, I check if the demo inventory exists. And if it doesn't exist, I use this AWX inventory create, which is this CLI utility to create an inventory. And then I create the project, and then I create a job template of this project. And so there are various levels of maturity that I've gone into that other people might already want to see, or a tool or something like that. And yes, then eventually this is how we log in. We configure this, and now Ansible, we run Ansible actually. we do a call to Ansible Tower, and Ansible Tower will log in and run Ansible in here for us, and we can then see the output in the Ansible. So we would see something like this. We can log in, and then this is what we will see in the command line if we call Ansible Tower with the AWX CLI utility. Here we can see that the job has been executed. This is the AWX Tower interface. This is the project space, and here is the details. And then when we add an inventory, I say it's already been done for you. And so when we run it, it would actually look, we can then call Ansible with a curl script, or we can use the AWS utility, or lastly, I'll show you how to run it with Terraform. So this is what the job looks inside, similar output to the command line. But then if you want to run it with Terraform, you can use this code. And the nice thing of using this little AWX utility is it's got this -- monitor flag. So you can see the Ansible output inside of your pipeline, inside of your Terraform apply. So if you can imagine that Packer would build it and spin it up. I just want to see if I can show you the output. Yeah, here's the output of this null resource. So this is complete Terraform. And then Terraform would connect to it and run the Ansible. And so now you can get your configuration and infrastructure together. Things like, if you consider like when a VM comes up, it needs to do a domain join. It might need to OU transition for group policies to take place, let's say for monitoring. If it's in the prod OU, then monitoring would take place on this. So there's various of things that you want to do at startup, that you might not want to do with a user data script. User data was always quite difficult to troubleshoot if the thing doesn't come up. But, once you can install Puppet in the user data and you can do a Puppet run, now it becomes very convenient because you can just keep on writing Puppet, pushing your code, and these things can just fly out, to new machines or current machines that the state. And to that extent, not all services can be containerized yet. There are still people that has to deal with VMs.
Cool. Will you accept a new implementation for Tiny Puppet?
I would love that. I would absolutely love that.
It's the point, because the point will be that it will install quickly any possible tool supported by Tiny Puppet inside the container, which actually could be useful for also testing. I don't know. I will give it a look. Maybe I will prepare a merge request and let's see if it's suitable for the.
That would be absolutely, what an honor if you were to make a merge request to this project. I mean, it would be absolutely an honor, I mean.
No, it will be interesting. Wonderful. Riaan, this is so cool. This Hashiqube is a gem, and I hope people, the few people who will watch this video will agree with me, because so many things, so many technologies together, and so smart. So wonderful job.
That's great to hear. In the end, I do it. I hope it helps people, especially students, because so many times you would go in an Uber or at a restaurant and you ask, "Oh, what do you do?" No, he studied computers, but now he's struggling to find a job. He has no experience. He doesn't have money to get an AWS account, and so things are very difficult for them. Where with this, I'm hoping to show them, if you want to use Terraform, you can use it. If you want to learn Kubernetes, you don't need to spend money. You can just take your laptop, install the Docker personal installation, and run this Hashicorp.
Yeah.
And so hopefully this works. But thank you again for having me on your show. I really appreciate it. What a wonderful way to spend the evening. Thank you very much.
Thank you, Riaan. At the next time. All the best.
Bye.